to prevent London from turning into a nuclear wasteland.
No. It's time for another video by Solve. Specifically, the Factory of Doom. That's Germany's nuclear weapons factory during World War II. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see.
This is Vemork, a factory laying deep within the mountains of Nazi-occupied Norway.
That is a lovely model.
At first glance, it appears to be an ordinary industrial plant, but looks can be deceiving, because this is no ordinary factory. Hidden in its basement lies the world's only large-scale production of heavy water, the final ingredient needed for Hitler to complete his atomic bomb.
Alright, heavy water, that's H2O, but the H is deuterium. I've also seen it written as D2O, is not a final ingredient for any type of nuclear weapon. It is a neutron moderator, not fissile material. That is to say, you can't make a bomb out of heavy water. You use it to slow neutrons down so natural uranium can sustain a chain reaction in a nuclear reactor, such as the CANDU reactors in Canada. And that's the trade-off. You're using heavy water instead of light water because it's a better moderator, so you don't have to enrich uranium in order to make a nuclear reactor. What Germany lacked during World War II was not heavy water, but enriched uranium or plutonium. And while you can make a reactor without enriched uranium or plutonium that uses heavy water, you can't make a bomb with it. The amount of reactivity you need is so much greater than you would ever need in just making a nuclear reactor for peaceful purposes. So calling heavy water the final ingredient for a bomb is a bit like calling a refrigerator your final ingredient for Thanksgiving dinner. It's a useful tool, but it isn't turkey.
A small team of Allied soldiers is sent on a mission to destroy the facility, a mission that will most likely cost them their lives. The Germans have stationed 300 armed guards and covered the surrounding area.
So, secret facility, but you're having a lot of guards for one area. Okay.
Areas with landmines.
Wow,
The factory itself is built on a steep mountainside, with only a heavily guarded bridge offering access. In every sense, the factory is the ultimate fortress. This is the story of what Winston Churchill called the most important sabotage raid of the Second World War, an operation that did not go as planned. This is the story of Operation Gunnerside, a mission to save the world.
Bit dramatic because this is just one facility for really a support system, which is only vaguely related to making nuclear weapons. It's not your dramatic raid to stop the enemy missile silo seconds before they launch, like in some sort of action movie. Not to dismiss the personnel that took place in this raid or their acts of bravery, but they were not that close to making a nuclear bomb, is all I'm going to say. Whoa, what is this depicting? Alright. Okay, mentioning deuterium. Not sure what the red stuff is. Blood? It's got nothing to do with the heavy water, but okay.
April 1940, Germany invades Norway. Facing little resistance, the country is fully occupied within 2 months. One of the key strategic reasons for the occupation was the establishment of the Atlantic Wall, a vast network of coastal defenses built by Nazi Germany along the western edge of Europe. Its purpose was to prevent an Allied invasion from Britain across
That is a cool effect.
the English Channel. The Germans also seized the opportunity to exploit Norway's natural resources, including timber and fish. But the country hides another resource that could decide the fate of the war. Back in Berlin, German physicist Werner Heisenberg was studying nuclear fission. He believed it was possible to create a weapon powerful enough to obliterate an entire city, a city the size of London,
Nuclear weapons are powerful.
The idea captivated the Wehrmacht, and the promise was a bomb no larger than a pineapple.
No. Depends what you mean by destroy in terms of its totality, but by most accounts, we're talking tens of megatons here, which even nowadays is sci-fi for something that small. There are nuclear weapons that are well above that requirement, but they're not the size of a pineapple. So you're not destroying a city, a London-sized city, with something the size of a pineapple. A 1 megaton airburst, which is way, way bigger than a pineapple and way heavier, on the order of several tons of material to not just act as the weapon, but to deliver the weapon to its target, could seriously ruin the order of 50 to 100 square kilometers, but Greater London is about 1,500 square kilometers. So realistically, we're talking multiple weapons. Something one person can hold in the hand the size of a pineapple. No nuclear weapon is that powerful per unit mass, at least as far as thermonuclear devices go. You're better off using multiple weapons. And all of this is completely sci-fi in the 1940s. And even if we had such a device, say it was possible to produce enough antimatter to do that, you could theoretically get 43 megatons per kilogram of antimatter, but getting a kilogram of antimatter is far more expensive than just producing a bunch of thermonuclear weapons. It's still sci-fi.
In a nuclear fission, heavy water can serve as a moderator. A moderator slows neutrons down, which is crucial for sustaining a chain reaction.
That is correct. They allow a reactor to sustain its chain reaction using unenriched uranium. And that's why the Allies cared, because without heavy water, the Germans would have needed enriched uranium, which they didn't have the infrastructure to make. Though this would be to make nuclear reactors that could theoretically, however, this is mainly for reactors. I mean, no practical weapon is going to be filled with heavy water to sustain it. It would be an intermediate step to make reactors that could also make stuff like plutonium, which could be used to make weapons. So it would be an intermediate step, but not directly.
But why didn't the Germans just use graphite as a moderator, like the Americans did? Well, they simply didn't know that they had to use so-called pure graphite.
Exactly. Early German experiments used impure graphite that actually contained boron, which is a strong neutron absorber, and is used in control rods to slow down fission reactions. So, this being the early days of nuclear programs, they incorrectly concluded that graphite wouldn't work. And the Manhattan Project had the resources necessary to purify the graphite to get the concentration of boron down to the parts per million level. And that is why Fermi's Chicago pile worked, but Heisenberg's pile did not.
Less than a month after the invasion of Norway, the Germans increased the heavy water production significantly. Back in Britain, this development caused alarm. They feared the Nazis were growing increasingly interest in heavy water.
So even with more heavy water, the Germans still lacked a working reactor. They never achieved criticality with their piles. They got as far as subcritical assemblies in Leipzig and Berlin. And no bomb program was ever really close. Heavy water was indeed a bottleneck, but it certainly wasn't the only thing holding them back. But in the context of intelligence, he's right that the Allied intelligence did fear the worst at the time. But little did they know that their physics and lack of resources did the majority of the job slowing down the program. And Operation Gunnerside wasn't the only thing that stopped.
Possibly to build an atomic bomb, the production had to be stopped. At first, the plan was to bomb the factory from the air, but the operation was deemed too risky. The plant was difficult to locate at night in the mountains, and any bombing raid would likely result in significant civilian casualties in the
air raid technology wasn't what it is today.
A nearby Norwegian town. The Germans had also strung 3 thick cables across the valley, designed to tear apart low-flying aircrafts. Even if a bomber managed a direct hit, it might not be enough. The heavy water facilities was buried in the basement.
That was a cool effect. It should look like it's dropping a glowing bowling ball or something. I like that.
Protected by a massive concrete slab, it was eventually...
Hey, in a way, that's good for containment. Having a decoy structure and then having a reinforced underground structure with a low profile, both in terms of sequency and in terms of it's not sticking very high above the ground where it can easily be hit.
Decided that the best chance of success lay in a glider-borne commander raid. Landing in a rugged terrain around the plant would be nearly impossible, but near the Møsvatn Dam a suitable landing site was identified. From there, the saboteurs would begin their journey towards Vemork, but the geography around the Vemork plant made any ground assault incredibly difficult. The factory was placed on the side of a steep mined valley. The only viable route was via a narrow suspension bridge, a bridge guarded around the clock. In secret, the Brits started Operation Freshman, a company of 34 saboteurs, carried by 2 wooden Horsa gliders, pulled by 2 Halifax planes. But before Operation Freshman can be executed, a group of hand-picked Norwegian soldiers are sent to Norway to prepare the landing site and escort the saboteurs to the target. This was Operation Grouse. All Grouse members were locals and had experience with the mountains surrounding the factory. Some of them even had experience in getting captured by the Gestapo, later to escape.
Wow. That's interesting, and it makes sense getting the people that were locally involved, know the terrain, know all of its secrets. Yeah.
Training began in early October and was designed to be relentless, not only to ensure that those who took part were at peak of their physical and mental fitness, but also to eliminate any men unable to cope with the difficult Norwegian winter terrain. The sappers were familiarized with the design of the plant and received training on the most efficient way to plant explosives to cause maximum damage.
That's a good way to train, using mock-ups, trying to get everything as realistic as they possibly can. That's the same reason why nuclear reactor operators have a simulator to test all of the crazy scenarios, some of which even seem somewhat unrealistic, just to make sure people know what to do in the event of an actual emergency. So the amount of prep that went into this is remarkable.
18th of October 1942, the Grouse team parachuted onto the Hardangervidda Plateau.
Wow. I wonder how many operations like this have been done at this point in history, this covert glider tow mission, and while dealing with severe winter weather.
Bomber turned back to Scotland. The crashes claimed the lives of 27 men.
Wow.
The 14 survivors were hunted down by the Gestapo, later to be eliminated. Operation Freshman was a complete disaster. Due to the secrecy surrounding the mission, very little information was provided to the families of the soldiers at the time, other than that they were missing. Back on the Hardangervidda Plateau.
And all this for to stop a nuclear weapons program that really wasn't doing that well. But of course, they just didn't know that. But one of the reasons why Germany's nuclear weapons program during World War II didn't go very well was it started out as broader research compared to, say, the Manhattan Project, which was a focused, dedicated program to make a bomb. This was more university and institute research with limited army involvement. So they did lab experiments to small reactor concepts. They did experiment with graphite, and heavy water became the most promising practical path, again, because of the experimental conclusions around graphite at the time. But no critical reactor, no large-scale enrichment line, and no plutonium production complex. So, wrong program. So they had the wrong problem framing and limited systems thinking at the time. Engineering scale-up was not the overriding mission. So there was a scientific prototype without a concurrent engineering and industrial plan. So they ended up with interesting data, but no deployable system. Again, a prototype lab pile is not an industrial scale plutonium breeder. enrichment plant.
The Grouse team is still
Sounds like the ideal choices, again, local personnel that have had experience fighting this enemy and giving them additional training, and they already have lots of survival skills. Yeah, it'd be your ideal case.
the members of the new team were once in the mountains.
Wow.
Snøstormene herjer jevnlig i området og virvler snøen inn gjennom sprekkene i den vesle hytta. Vi er tomme for mat, og kreftene siver sakte ut av oss. Alle blir rammet av sykdom og feber.
That's brutal.
Da julen nærmer seg, har vi ennå ikke felt et eneste vilt. Den eneste næringen som holder liv i kroppene våre, er mose og rester av stearinlys.
Wow. That's... I mean, if you're hungry enough, you gotta do what you gotta do.
Their days are short. They rise at daybreak, but by 4 in the afternoon, it's already dark,
Yes.
leaving them with nothing to do but to crawl back into bed, conserving what little energy they have. But then their luck changes. On December 23rd, Paulson sets out for his usual hunting ground when he spots a herd of reindeer. Adrenaline surging, he drops to his knees and takes aim. He fires. The herd scatters. He fires again, but none of the animals fall. Then, following the tracks in the snow, he sees blood. Further ahead, he finds a downed reindeer. He drinks a cup of its warm blood.
This is an interesting direction he went with this, going over the survival story and everything, but hey, that's part of it in the historical context.
And carries 20
Wow, sounds like the hardest part of the mission was just getting there. That's...
Grouse had discovered a path that avoids the heavily guarded suspension bridge. It's a risky route involving a steep descent down the icy gorge, but it might just work. Under cover of darkness, the saboteurs climb down the ravine, crawl across the frozen river, and scale the vertical cliff on the other side. They reach the back of the plant, cut through the perimeter fences, and enter the courtyard. To reach the factory's entrance, they must pass a German barracks, where enemy soldiers are gathered just meters away. They press themselves against the wall.
One thing is, if this really is just a heavy water production facility, there's not really much in the way of radiological hazards here. It would just be the standard chemical and physical hazards you would see at any large-scale factory or production facility. But nothing on the level of, say, if they were in, say, a plutonium enrichment plant, for instance, where they'd have to deal with plutonium itself.
Sliding past the windows in silence, preparing for the worst. They reach the main factory door. It is locked, but this does not come as a surprise. They know of a ventilation shaft nearby that leads directly to the basement. Inside, the corridors are empty. They move silently. The entire layout is memorized. A German voice suddenly echoes outside. They freeze, but the footsteps fade into the distance. At last, they reach the heavy water electrolysis chambers, where only a steel door separates them from their objective. In one swift motion, they breach the door. To their surprise, they encounter no resistance, just a Norwegian caretaker who is more than willing to cooperate. They quickly place explosives on the vital equipment. The charges are perfectly measured, powerful enough to destroy the machinery, but quiet enough to not alert the entire valley.
Nice.
Just before setting the fuse, the caretaker intervenes. He asks politely if they could help him find his glasses, because it is impossible to find new ones during the war. They oblige. Once the glasses are found, they light the fuse. As a final gesture, they leave behind a Thompson submachine gun, a clear sign that this was a British-led operation to protect the local Norwegians.
Oh, interesting. Okay, so they don't essentially clamp down any harder than they already had on Norway.
From retaliation. The raid is a success. Over 500 kilograms of heavy water are destroyed,
Wow, look at that.
along with key electrolysis equipment.
So destroying this would have certainly slowed down the research, but the Germans could always rebuild, and they did. The key thing, in addition to this raid, was later sabotage bombing campaigns, and they also sank a ferry in 1944 that carried even more heavy water. But this was important in specifically targeting this sort of research and weapons programs, even though it was far away from development. But it did show a precedence of, hey, they weren't going to tolerate the enemy making things that could, down the road, eventually lead to making nuclear weapons.
Although 3,000 German troops are dispatched to hunt them down, the saboteurs all escape without a single casualty.
Wow.
The Germans were later able to rebuild the plant and resume making heavy water. In November 1943, the Allies launched a massive bombing raid involving 160 American B-17 bombers, hoping to cripple the facility. However, the raid caused only limited damage to the plant itself due to its thick concrete floors, and tragically, 21 Norwegian civilians living nearby were killed. Subsequent air raids also failed to halt production entirely. But by then, the damage had already been done. The German nuclear program had been delayed beyond recovery.
And again, not just in the case of the one raid, because their program wasn't exactly doing very well. It would never be completed within the timeline of World War II.
They would never have a working bomb before the end of the war in Europe.
Yep.
How much time the raids on Vemork actually cost the Nazis is still debated, but the saboteurs may have brought the Allies just enough time to prevent London from turning into a nuclear wasteland.
No. The Germans were never close to building a bomb. Even without sabotage, they lacked the industrial scale enrichment facilities like Oak Ridge National Lab or a reactor like Hanford to breed the plutonium. I mean, saying London was spared, that's good drama, but it's not good history. The bomb program was mostly theoretical papers and small lab piles. So in addition to their materials problems and them getting wrong about graphite and their limited manufacturing capabilities, they also had not the best organizational structure. Work was split among the university groups, the institutes, and branches of the military. No single manager had authority or the funding to convert lab work into a factory program, compared to Leslie Groves plus Oppenheimer in the case of the Manhattan Project, who had a unified command structure, huge budgets, prioritized industry access, and all the power to requisition resources on a cutting-edge new weapons program. Not to mention, in Germany during World War II, many top physicists had fled Germany in the 1930s for obvious reasons. So loss of key talent, which ultimately ended up helping the Allies, also made their program even worse. It just wasn't even close.
An achievement a little more significant than a YouTuber sitting in his bedroom only having to deal with his comment section. I get a lot of...
All right, that was funny. Overall, this was a good one. I especially love... Overall, the effects were amazing, but it just really needed more nuclear context. If you haven't seen his video on the task to build the Chernobyl sarcophagus, highly recommend you check that one out too. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.